Okay, let's jump into chapter 19. In this unit, we're going to be covering aldehydes and ketones in one chapter, and then all of our other carbonyl-containing compounds in the next. So, more than ever, it's super important that we stay organized, that you pay attention to what functional group is in the starting material, because you're going to see some similar reagents throughout the chapters. An aldehyde and a ketone behave very differently than carboxylic acid and their derivatives. So just know that going in. Let's make sure that we recognize these functional groups. Right, an aldehyde is going to have a carbonyl with at least one hydrogen attached to it. Formaldehyde being the smallest aldehyde with 2 hydrogens. A ketone should have an R group on either side, so 2 methyls would be the smallest, and that's here with acetone, right? It's important that you recognize that an R group is a carbon, right? And a carbon, at least this first connection. So no oxygen, nitrogen, hydrogen, etc. The way that Klein sets up all of these chapters, right, of course, we present these ubiquitous functional groups, and then we show you just a random assortment of things that they're in. So here we're seeing an assortment of naturally occurring aldehydes and ketones. We're going to do the nomenclature up first. There's a lot of nomenclature in this unit. You definitely need to be practicing. It will be a significant chunk on the next exam. And anytime we do functional groups, you are going to see these 4 basic rules. We need to identify and name the parent. We need to identify the substituents. We need to number. And then we need to assemble and organize it correctly. This is where, if you are feeling weak on your nomenclature background, it's time. You need to do practice with it. So we'll do a bunch of practice here, and we'll talk about the new rules. So we're going to start off with aldehydes. I don't know why I prefer blue, but that's what I want. So we're going to start off with aldehyde nomenclature. So we're going to talk about naming the parent based on the highest priority functional group. Well, the aldehyde is the highest priority functional group that Klein has introduced so far. I will give you a priority list at the top of your next exam and exam 4 in the final. So you do not need to memorize the priorities. But whatever is highest on the list, we want the longest chain containing that high priority functional group. So when we think about the aldehyde, we're looking for the longest chain that has the aldehyde, and then we are going to take that parent, whether it's an alkane or an alkene or an alkyne, it doesn't matter. You would keep that letter there, the A, E, or Y, to let you know about the straight chain. And you would drop just the E and add AL. So it's very similar to how we name alcohols, but you have an A instead of an O. Let's see. You're fortunate that you're going to be typing and not handwriting this for me, because your handwriting won't play a part, but you have to be correct in your spelling here. I don't typically take off for misspelling unless it changes the meaning, and an A versus an O here changes the meaning. So we see some very simple examples. Butane becomes butanal when you have an aldehyde. You notice you do not need to number it. An aldehyde is always going to be on the end, and then it will always be carbon 1. Whatever is giving you that high priority, the parent name, it takes the priority for numbering. So for aldehydes, it would be number 1. Now, I often show you how to name some functional groups if they are substituents, but we are getting to some of these really high priority functional groups, and some of them I won't show you how to name as a substituent. If I don't show you, then I wouldn't ask you to do it. So aldehyde is one of those. If I give you an aldehyde, it will be the highest priority in that compound. You can see here an example of choosing your parent based on the longest chain with the functional group. Here it's just a simple alkane, so the longest continuous chain would be octane. But now when we introduce this aldehyde, we want the longest continuous chain is still 8, but the longest chain with the aldehyde is only 6. So this would be a hexanal, a propyl hexanal. Now let's go ahead and just practice on this one and give it a full name. So you can see the correct numbering here. You can draw that into your notes. I'm going to go ahead and name it. Actually, let's name it right on the slide so it's not confusing. Here we go. You're numbering to give the lowest numbering to that high priority functional group, so to the aldehyde, and then everything else follows. Even though that gives more high locant substituents, first and foremost is your aldehyde priority. So this becomes, let's see, we've got 2 methyl groups, we've got a hydroxy, and this is an alkene. So this is based on heptene. This is going to be a heptene al. We do need to number that double bond, and so I'll show you how I do it. So we're going to write things down alphabetically. So 5-hydroxy has to come first. And then we have 2 methyl groups. So it is a 5,6 dimethyl, right? You don't include those Greek prefixes in your alphabetizing. H comes before M. Then we do need to say where the double bond is. You can put it before the parent or within the parent. When we have multiple suffixes going on in our parent, I like to put it inside. So for me, this is how I would do it. Hept 6-ene al. Then it's just very clear. The 6 goes with the ene. I just put it right next to it. You could also call this 6 heptenal because you know that the Al is on carbon 1. Let's see. Let's do another practice problem because I do want to point out a couple of things. So let's say, I'm just going to make a complex one here for us. Let's put a bromine here. Let's put a bromine here. We'll put our aldehyde. All right. This compound has both a chiral center and a double bond that has stereochemistry. There was no stereochemistry to be reported on this double bond because there were 2 H's, right? There's no cis or trans E or Z around that. If you do not remember E and Z and R and S, it will not keep you from making a good grade, but it will keep you from getting 100% of the points because I will always throw in at least one of those into the name, and to get full credit, I want you to give me the fully correct name. So if I give you something with a chiral center and it shows the stereochemistry with a wedge or a dash, I expect you to be able to handle it. So before we jump into naming, let's assign R and S to this chiral center. So the bromine is 1. What isn't shown might be important to add in. It is 4th priority, but it's a hydrogen, and it's going away from us. The carbon to the right is attached to carbon, and bromine, so it beats the carbon to the left, which is a CH2. Now, these 1, 2, and 3 connect counterclockwise, and the 4th priority is going to the back. So this is an S chiral center. Now, for the double bond, if we're trying to figure out E and Z, let's change this up to green. Here we go. You're going to cut down the middle of the double bond. Might be helpful to add in any hydrogens. And then you're going to do the same priorities, but you're just going to get a 1 and a 2. Bromine is higher priority than carbon. Carbon is higher priority than hydrogen. So my 1s are on the same side of the double bond, or cis to each other. So this is Z. This is the same side. My bad German accents, how I remember that. If E would be if the priority ones were on the opposite side. So I have all my stereochemical information and I've numbered. So let's go ahead and name this guy. I'm going to go ahead and copy this and take it with me to somewhere where I have some room. Paste. There we go. Let's name this kid. All right. So I have 2 bromines. So those are my only substituents. And they are on carbon 1, 2, 3, and so 3 and 4. I have a 3,4. Actually, hold on, I am messing up. This is an S compound, so I'm going to report that first. I'm going to go ahead and put that at the beginning. You can put a number or not if there's only 1 chiral center. You should put the number with it if there is more than 1. So in this case, if you were going to put a number, you would put 4S. Then it is 3,4-dibromo. And then this is a hexene al. And you could put the Z out in front, or I also think it's appropriate if you put it with the number. So my double bond is on the 2 position. So it's a 2Z hexene al. All right, so all the little pieces that you could possibly ask for in this example. After that, we will move on to ketones. So ketones are pretty simple. You do have to say where they are because they will not be on carbon 1. They can't, then they'd be aldehydes. And for anything bigger than butanone, you have to tell where it could show up, right? With butanone, it's got to be on carbon 2. That's the only option there. If the ketone wasn't the highest priority functional group, you probably would want to number it. So if I was doing this naming, I probably still would have put 2-butanone. Can't go wrong with telling us where the ketone is located. Again, we are looking for the longest continuous chain with our highest priority functional group. Now, ketones are lower priority than aldehydes. So before we're done naming, I'm going to show you what to do if you have both. But for now, if the ketone is your highest priority functional group, and let's say we have something like, let's put this here, something like this. Your highest priority functional group is your ketone, but your longest continuous chain might not contain it. Well, for the parent, it has to. So our parent's going to be 1, 2, 3, 4, 5, 6. It's going to be a 2-hexanone. So for this one, on carbon 3, we have a propyl. And then I do need to say where that ketone is. And you can put it in the parent or in front of it. When it's an alkane, it's easy enough to see. If it was a hexenone, you might want to put it inside. All right, so you could also do hexan2-one. There we go. And you can see they show you that same information in their example with heptanone. All right, what I want you to note here, you can skip this right here. I am not going to ask you about carb aldehydes, or basically when these are coming off of a cyclohexane. I will not include that in any of my problems that I give you guys. I'm not sure why this shows up here, but it's just another chance to practice some of the different things that can come up with nomenclature. Now, we just learned about benzene rings in the previous unit, and so we should know how to name them as a substituent, right? The highest priority functional group, aromatic, is rather low on the list. The highest priority functional group would be that aldehyde. So this would be a propanol. It's important to remember that a carbon cannot both be in the ring and in the open chain. If it's in the ring, it's in the ring. All right, so this is not a butanol, it's a propanol. The chiral center, you would be expected to be able to provide RNS. Let's just review just to make sure. 1 is the chlorine. In this case, the hydrogen is wedged. That's number 4. A carbon bonded to 2 oxygens would be higher priority than a carbon bonded to carbon and 2 hydrogens. So again, this is counterclockwise, but since priority, this is an H, since priority 4 is coming towards us, it's the opposite of our rule, and so that is how they get R. You should know a few common names. So common names that you should have memorized should be formaldehyde. Now, formaldehyde is also, IUPAC name is methanal. You should know acetaldehyde. This one would be ethanol. Benzaldehyde you had to memorize in the last unit, so you should know that. And one to add here, the only ketone that I would expect you to memorize would be acetone, right? And that is going to be your 2-propanone, right? So formaldehyde, acetaldehyde, acetone, just to be consistent, we'll provide that there. And then benzaldehyde. So you should know these 4 common names. Now, this isn't in the slides, but I expect you to know it. What to do with ketones when they're not high priority. So when they're just a substituent on the parent. They're really easy to name. They are oxo groups. So for instance, we could, oh, I don't know why I'm doing that. Well, okay. We're going to name a couple of things here. Then let's do an aldehyde. Put a couple of ketones on it. Okay. This is really the one I wanted to do. So what would this guy be? Let's put a little double bond in there. Now, what's the parent here? The parent is a cyclohexene, and it has a carbonyl on it, which is a ketone. So it's a cyclohexene-one. I wanted to do this to show us to talk about numbering a little bit. 1, 2, 3 is the appropriate way to number this. Whatever's giving you that parent name, that own should be number 1. But then you should number to give other substituents or functional groups the lowest numbering possible if you have a choice. So going counterclockwise here is how we handle that choice. So we would say that this is a cyclo, and this should all just be one word. Hex, 2-ene. And you don't have to put 1 because it's a cyclic compound, but just to get in the habit, I'm going to go ahead and put the 1. And that's how you could handle an enone or an inone. Now for this one, the the aldehyde is the high priority functional group. Again, you can't have a carbon in a ring and outside of a ring, so that cyclopropyl group is a substituent. This is a 1, 2, 3, 4, 5, a pentanal, with 2 oxo groups. So alphabetically, cyclopropane is going to come before oxo, cyclopropyl. Then on carbon 3 and 4, you have 2 oxo groups, and then pentanal. Pentanal. Definitely practice. Your old exam that's up on eCampus has some nomenclature practice. I will link you to a few other nomenclature practice sites. Don't assume because each small new rule is easy that you got this without practicing. There are a lot of small new rules. In the next video, we will get into some reactions.